Yeah, so hello everyone. This is our first podcast in the series of whatever work we have done, our forgery detection and the forgery detection in terms of images, videos, and text. I have along with me Dr. Arun Sharma and Dr. Motahar Reza. So Dr. Reza has associated with from last 1 year, and we are continuing working along with this. And Arun Sharma has joined us, and he is just moving into the things really with a good pace, and we are able to give make a really good improvement in terms of research what we have done. So Dr. Arun Sharma, can you give us our first article what we have published recently in our website? So can you give a brief overview about it?
Thank you, Arvind. Here on our website, if we go to blog, then scroll down, we'll see here the link for the first article. If you click on more, you will see the article, and we can read here or we can download from here. So this article is basically for data augmentation using GAN adversarial network for forgery detection. So if we talk about the forgery detection is a typical real world application where we can see that for this application what we need a database which will have original images as well as fake images or the forged images. Our objective with team is to develop an intelligent system which will be capable to identify whether the test sample is forged or real or original image. For this training, we need require to train some deep learning model or advanced deep learning model. And training advanced deep learning model requires a large database, and that database should contain original images as well as forged images. And having forged images, a large number of forged images along with the original image in real world scenario is a bit time consuming, and sometimes it becomes infeasible because it needs manual work to create the forged database. So for this situation, we have presented the application of GAN to synthesize images for both class original as well as forged class of samples. GAN really helps in this case, such type of situations, because GAN has adversarial training mechanism. I'm presenting here briefly the theoretical background of GAN, how it works. GAN has two CNN model. One is called discriminator and another is generator. Here, discriminator and generator helps each other to train both the network. Discriminator is capable to identify whether the image is the real image or the fake image, and the generator takes random noise, and using that random noise, it random noise is transformed into a image pattern that is similar to the real image. As we start the training, how it works, GAN generator inside the GAN generator part of the GAN takes the random noise, and it is transformed and created some image. And that image, the created image, goes to discriminator. Discriminator tries to identify whether that image is from the real image database or the fake image database, and generates a loss, and based upon that loss generator is trained such that generator tries to generate images as close as to the real image, and discriminator is trained to identify such that the fake image, even if GAN is perfectly trained. Training purpose, here the purpose of the training is adversarial to both each GAN and discriminator. GAN tries to generate image as close to as real such that discriminator is unable to discriminate, and discriminator train itself to identify even if GAN is perfectly generating the image close to the real one. This mechanism we have presented for the two cases. Two example we have taken, and we have implemented the GAN using PyTorch library of Python, and the architecture that we have selected is presented here. Summary is presented here, and we have applied for two purposes. One, the creating the synthetic image for leaves data set, and another for the face data set. Here is the samples of the real image of the leaf data set, and using this real image database we have trained the GAN architecture as I shown, and synthetic images is shown here. We can see here that with epochs of training, the synthetic images are something trying to be similar to the real image. With 10 epochs, we can see it looks like distorted leaves. And as we increase, we go on with the training, the synthetic image is becoming closer towards the real leaves data set. Similarly, other application for the GAN is used for the generating phase data set. Here, this is the real faces that has been used to train the GAN model, and after some iteration, we can see these are the faces generated after some iteration, and then after 300 epochs, 100 epochs, these are the faces, and after 300 epochs, these are the faces that has been generated and synthesized. So, to conclude this, we can see if GAN is sufficiently trained with given real database, GAN is capable to generate images as close uh, to the real images, and therefore the generated images can be used to augment the real data and increase the database for general training of the deep learning model. Yeah, that's it.
Okay, thank you, Dr. Arun. So it has given a good insight at how it does work, and I'm really surprised at how GAN can be really useful in our, creating this sort of complex data set and using it in practical life. It will really help us in doing the some solving the some real life practical solution. So I have one another question. What is the difference between real images and GAN generated images?
Yeah, we can see by comparing these real sample of the leaves. These are the real samples of the leaves data set, and these are the synthetic images. Synthetic images looks as close to the real images. When GAN is trained, generator weights are updated such that generator is capable to generate image pattern similar to the real images. So basically, GAN while training try to capture the distribution of the real data samples. So once GAN has captured the distribution, how images are being distributed. So GAN generates similar distribution or pattern of the image that we have used for the training. If GAN is sufficiently trained, the synthetic image is close pattern or distribution, feature distribution of the synthetic images are close to the real images, but actually these are not the real images. This has not been created with some digital device like webcam or camera to create it. But these are the just image distribution created artificially with CAN model.
Would like to add one or 2 points here. Dr. Orun is nicely described that actually that difference of the real images and the GAN generated images. Yeah, the real images is taken by that your the device actually. So that our main objective is to create the sample. So when we are using the samples, we are using some digital camera or digital device, but there is some error should be there actually collecting the data. Now from that sample, that our main objective to understand that actual the population distribution, which is not always unknown, but the GAN model is helping to understand that distribution and to generate virtually to the similar distribution or that synthetic data. So in the case, the real data is a costly in the sense of the time or physical manpower, where this data can be used and get that same result, or maybe sometimes the better result with respect to that real image. And that is already theoretical, that this is a totally statistical approach, which is that based on that adversarial models. So we are using this statistical approach to get some advantage to create that synthetic data. And theoretical, what is telling, our Dr. Orun already presented that our work with the accuracy is real is very good, and we are satisfied with that augmented data. Thank you.
Yeah, right, Dr. Reza.
Thank you, Dr. Arun. Thank you, Dr. Reza, for the insight. And I have the another question. What are the challenges you faced while using GAN to improve the performance of a deep learning model? So, can you give a little bit insight how what are the challenges while doing the accuracy of we achieved around 95, 96%. So, what are the challenges you faced really?
Yeah, GAN, while using GAN for the data augmentation, of course, we are using this to create synthetic image and add to the real database so that we'll have increased data samples. So first challenge is that for training the GAN, still we need a sufficient number of real data samples so that GAN will be capable to capture all type of distributions of the images in the real samples. And once it is trained, GAN will randomly generate all those features, all those patterns in the synthetic image also. Second challenge is that GAN should be sufficiently trained so that GAN generator loss and the discriminator loss are optimal enough so that GAN after the final GAN model will be capable to generate image as real, as close to the real image. The main challenge is that we should have sufficient or significant amount of computational resource so that it can be trained large number of epochs. Yeah, that's it.
Yeah, I would like to add on one or two lines. Mainly, the GANs is having the two network actually, which is based on that two CNN models. One is that a downsampling of the discriminator. Another is that your upsampling of that your generator. So, which that convolution operation is done. So, generator is doing this. It is a transpose convolutions, and the discriminator is doing that normal convolution. So big challenge of the design of the network, how many layers, how many convolution layers will be there. Then that good accuracy means you have to the regulations part to that good fit. So and for that reasons also the Dr. Arun already mentioned, we need a huge computational resources which having that large number of the epoch if we run it. So then we can get that actually proper GAN model, which will create that a similar characteristic or the same characteristics what is having the real data, and that your augmented data will have the same distribution. Okay, thank you.
Yeah, any
Thank
question?
you, Dr. No further question. I think it's quite clear now. So maybe anybody who is listening to our podcast, they can, our write their questions in our YouTube channel, and then this podcast will be there, and we can help them with their questions, or if they need some help or any work. So we'll be gladly able to help them, and any questions require, any help require, we'll be able to answer them their question or answer. So it will be in YouTube, our channel, it will be live, so that in future any questions are there, another podcast will come follow up, so that we'll do it for another article. So so all the question can be answered there, or maybe some our email address will be also there, also can, you can ask the question and answer. And also the Next part of our article will come in coming a week or two. So we'll be again gathering here and trying to display our work in research area. So Dr. Arun and Dr. Reza are working in text forgery and end-to-end forgery, and we'll collect it and then we will make a good product or services which will be available through our website in future. So kindly stay tuned and to our YouTube channel, and we'll be keep coming with more information. Looking forward to your feedback. Thank you. Thank you, Dr. Reja. Thank you, Dr. Arun, for your contribution, and looking forward to work further.
Okay,
Thank you,
thank you, Arvind.
Doctor. Yeah, Dr. Orun also. Thank you.
Thank you. We are closing our podcast here. Thank you.